Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at Pascal's triangle. This is now really where the A-level stuff really gets brand new. You've probably not seen Pascal's triangle before. If you did further maths at GCSE, you might have done, I'm not too sure, but it's definitely going to be new for quite a lot of you. Now, on the screen, I want to consider the expansion a plus b to the power n for 5 values of n. When n is 0, when n is 1, all the way up to when n is 4. Okay, and I've already actually written this out so it's nice and neat. Here are the 4 values for, or the 5, sorry, values for n, and here are the 5 expansions. The first one is when n is 0, so we have a plus b all to the power of 0. Doesn't matter what we've got inside the bracket there because we have a power of 0, and so that is of course going to be 1. Anything to the power 0 is 1. If we have n to be equal to 1, then we've just got a plus b to the power of 1. We don't really need that power of 1, it's just going to be a plus b, just like that. Now, I am just going, as I go down, to highlight these values, okay? Those are the coefficients of the expansion of these brackets, okay? So I'm just highlighting the coefficients there, basically the numbers. Okay, when n is 2, we have a plus b squared. That's just a plus b multiplied by a plus b. And hopefully by now we know exactly what that is without even doing any working out. You can see we have a squared plus 2ab plus b squared. Again, highlighting there the coefficients. Then when we have a cubed, we have a plus b times a plus b times a plus b. Work that out if you want to, have a pause and see if you can work it out. If not, this is what you get. You get 1a cubed plus 3a squared b plus 3ab squared plus 1b to the 4. And then finally, right at the bottom, we have a plus b to the power of 4. All we're doing here is just changing the value of n as we go. We're increasing it by 1, okay? We have a plus b to the power of 4. And that is this expansion here. Let's do some highlighting. We have 1a to the 4 plus 4a cubed b squared plus 6a squared b squared plus 4ab cubed plus 1b to the 4. As you can see, I've written it so that it makes a triangle. That's because we are looking at Pascal's triangle. So Pascal's triangle actually originates from the coefficients of the expansions of these brackets. All we've done to get this is expanded these brackets here. I've chosen to use a and b inside the bracket. You could have used anything, x and y, p and q, doesn't matter, because all we're interested in is the coefficients. Okay, and you can see I have these, or this coefficient, joined to these two. The two directly above it are joined together. This coefficient here, again, is joined by the two directly above it. And the reason for that is this, okay? The coefficients in the expansions form Pascal's triangle. The reason is because in this Pascal's triangle, if we were just to maybe have a look at these orange ones here, if we add the coefficients of these two together, add them together, it gives me the coefficient of the term directly under these two. If we look at the lines connecting them, we've got a 1 here and we've got a 3. Directly under those two is this term here with a coefficient of 4. Adding those two coefficients together, we get a coefficient of 4, which is what we have directly underneath. We could look at this one here. We've not got lines joining these two together, but we've got a 6 here, and that comes from this coefficient added with this coefficient because they're directly, or this is directly under those two. And that's how we can work out the coefficients of expansions like this using Pascal's triangle. So here is Pascal's triangle without the brackets. We've got rid of the a and b now, and we're just looking at the coefficients. Okay, these coefficients just come from all of these yellow and orange and green highlighted numbers here. They come from expanding these brackets, but I'm getting rid of the brackets and I'm just taking the coefficients. Coefficients are the numbers in front of the brackets. So that's what we've got going on here. Now, you can see I've labelled the rows. Row 0 is what we start at, and the reason for that is so that they line up nicely. Okay, row 0 is if we expand the bracket using a power 0. Row 3 here is if the coefficients, if we expand the bracket using a power 3. Okay, if you don't do that, so just for example, ignore these for a minute. How can I get rid of those? Let's just rub these out for a minute. If you don't do that, and you don't class the first row as row 0, then you need to just know this. And some textbooks don't have it as row 0. Okay, if you consider this as the first row, this is the second, this is the third, then if you're trying to expand a plus b to the 3, for example, you want to have a look at the n plus 1th row. So we were having n as 3 here, a plus b cubed. So we want the cube, but we don't want the third row. We want the 4th row. We want to add 1 to that. So 1, 2, 3, 4. This is the expansion for a cubed. Okay. However, if you do consider it with a row of 0, then you don't need to consider that rule because you're starting at row 0. So squared, these will be the coefficients. Okay. And again, note here, it might be a little bit clearer, if we have this directly underneath this 5 comes from a 1 plus the 4. Here comes from the 3 plus the 1, we get the 4. And you can look at any of them really. You can look at that 15, gives you, or you get it from having a 5 with the 10. Okay, here you could have this 2 from the 1 and that one there. If it's always directly above, makes the one directly under. What else can we note about it? We can note that all the way down the edges is always 1, and that's because we always have a coefficient of 1. If you look at the expansions here, no matter what the expansion is, we always start with a to whatever the power is, just 1 of that, and we always finish with b to the power of whatever it is, always 1 of them. That's where we get our 1s coming down the triangle like that. Okay, so Pascal's triangle is formed by adding adjacent pairs together. We know that, and we also know if we don't consider it being row 0, we know that if we are expanding cubed, we need to look at the 4th row. Okay, so let's have a look at an example. We want to use Pascal's triangle to find these expansions. Now, I'm going to do this with you, so you don't have to pause if you don't want to. Maybe we'll do A together, and then you can have a go at B. So, A is a cubic expansion, and we have an x and a y. We're adding those together, and then we are cubing everything. So what we want to do is we want to have a look at the 4th row of Pascal's triangle. You probably would maybe use Pascal's triangle, so let's do that, okay? It's telling you to do that. You might get that in an exam. So I would write down Pascal's triangle before we start anything. We always start with a 1, and then we either side are going to have a 1. And then now we can start doing our addition. We start with a 1 again. The 1 plus the 1 will give me the 2, and then we finish with a 1. There's always 1s running down the triangle. We've got a 1, and then the 1 plus the 2 will give me a 3. 2 plus the 1 will give me a 3, and then that 1 is just on the end. Okay, that's the 4th row of Pascal's triangle. We have a cubed here, so I'm going to use the 4th row if we're not considering this 1 to be row 0. Okay, if it's row 0, then it is actually row 3, but it's the 4th row down in the triangle. These are going to be my coefficients for the expansion. Now what I want to do is I want to expand, and this is how we come up with the powers of the letters, okay? So we always start with this term here to the power of what the bracket is. So it's x cubed, okay? And in fact, I'll write it like this, x plus y cubed. And it's actually going to be 1x cubed because that 1 there is the first coefficient in my expansion. The second coefficient is going to be the second number in the row of Pascal's triangle, which is a 3. okay? So that 3 is going to be the next term. But what are the powers of x and y going to be? Well, what we have is we have an x cubed here. So when we go along the terms, the x is going to decrease in power. So the x on the second term is going to become x squared. The first term it was x cubed, so the next one it's going to be x squared. But really what I maybe should have done to make this super clear is also in that first term, we do actually have a power of y. We actually have, and I'll write it in green, y to the naught, because anything to the power of 0 is 1, so that y to the naught just kind of cancels, it disappears. It's just a multiplication of 1, okay? So the x has decreased in power, now the y is going to increase in power. So I'm going to have y to the power of 1. I'm going to keep it as power 1 in a minute so I can show you something to check your answer is correct in a minute. And that's our second term. We started with just x cubed because that was the power of the bracket, and then we've decreased the x power by 1 and increased the y power, this second term inside the bracket, we've increased that by a power of 1. Then we are going to add the next term, and the coefficient is going to still be a 3 because that's the third term along our row. So we're going to have plus 3, okay? And let me just, I'm going to do that in a different colour. I'll do that in green, so I can highlight that in green there, okay? So that is where the coefficient comes from, it's the red one, okay? And again, we want to decrease our x power by 1. The second term had a x power of 2, so the third term is going to have an x power of 1. And then the second term had a y power of 1, so we want to increase that y power by 1 to give me y squared. Okay, the more practice you do, the easier this will become. So then we still are going to have another term because we've got a power of 3, so we're going to have 4 terms. If we had a power of 5, we would have 6 terms. It's always one more than your power. And we can still see that as well because we have, and I'll use a different colour, I'll use a purple, we have this coefficient of 1 still to be done. So we're going to add a coefficient of 1, but what is our our x and y going to be here? Okay, well, we're still going to decrease the x by 1, and I'm going to write it in green because it's x to the power 0, and we're going to increase our y by 1. So we're going to have y cubed. And now we can just simplify that quite nicely. Okay, we've got 1. I don't need to write the 1, so I can just write x cubed. We still need that 3, and it's 3x squared y. I don't need the power of 1. I can add 3x, don't need the power of 1, y squared. And then I don't need that purple 1, and I don't need the x to the naught because it's just a 1. So I'm just going to have plus y cubed onto that. And that's the expansion. The more you do with Pascal's triangle, the easier it's going to become. And the more you do, you actually remember the coefficients, okay? Of course, if you had a coefficient of something like 10, you might not remember the coefficients of the power 10 on Pascal's triangle. But maybe with a 3 and a 4, you might remember these coefficients and the next row as well, okay? So that's what we do. Now, I want you to notice something about the powers. The powers on the x and the y always add to the power of the bracket. So look here. If we look at this second term here, okay, we have a power of 2 on the x and a power of 1, which we just don't need to write. We can see it here actually. I'll do it in red. We have a power 2 and a power of 1. Adding those together is going to give me 3. And 3 is what the power on the bracket was. Okay, so the powers always add to the power on the bracket. And that's how you can check you've actually done this correctly. Okay, here we've got a 3. We know we've got an invisible y to the naught. 3 plus naught is 3. That's good. X squared, which is a 2, and then a y to the 1. 2 plus 1, like we just did in this example here, is a 3. 1 plus 2 from this terms here is a 3. x to the 0, 0 plus y to the 3. 0 plus 3 is 3, so that works. That's always the case. We always want them adding to the power. And the first term here, x, decreases its power as we go on, and this second term, y, increases its power as we go on. Okay, that's how we do the expansion using Pascal's triangle. So that was part A. Part B, see what you can do with that one, but be careful because we have a 2x here. So that's going to change things a little bit, okay? We've not just got coefficients of 1 inside the bracket now, we have coefficients of 2. So pause if you want to, be careful of the negative as well, just see what you can do. Even if you don't get a final answer, just have a think about it, then press play and we'll work through the answer. Right, the first thing I'm going to do is I'm going to work out what my coefficients are going to be. I am expanding with a power of 4 here, so I'm going to need the 5th row of Pascal's triangle. It's row 4 if you think about it as a row 0, but it's actually the 5th row of the triangle. So I'm just going to move this down a little bit, just so I can do this. I can have a 1, I can have a 4, I can have a 6, I can have a 4, I can have a 1. That came from adding these together to give me the term that's directly under. And then we've just got 1 on either side there. Okay, so what I want to do is I want to do this expansion. Now, this is my first term, 2x, minus 5 is my second term. In other words, we had x and y here. X is now 2x and y is now minus 5. So we've actually got some numbers here. Right, this expansion is going to look like this. We're going to have the first coefficient on row 5 because we're doing a power 4, so it's on the 5th row down. So it's going to be the first coefficient, which is a 1, multiplied by my first term in the bracket, which is 2x, multiplied by 2x to the power of 4. And the second term to a power of 0, if you want to be precise. Okay? That's the first term. The second term is the coefficient, the second coefficient along, which is a 4, multiplied by 2x, reduce the power by 1. We had a power of 4 in the previous term, so the second term, 2x, is going to be a power of 3, and then multiplied by minus 5 to a power of 1. And again, check here, we've got a 4 and a 0, add those together, we get a power of 4, which is good. 3 plus 1, those are my powers, add those together, we get 4, which is the power on the bracket, so that's good. Okay, let me get rid of those so it doesn't confuse us too much. And let's do the third term now. I'm just going to go on the second line. The third term is going to have a coefficient of the third number along, which is a power of 6. Okay, or a coefficient of 6, sorry. So coefficient of 6 multiplied by 2x, reduce the power, let's speed up a little bit now, and increase the power on the second term. Then we're going to have a coefficient of 4 with a reduced power here, so that's a 1, and an increased power minus 5 cubed. Okay? That is adding to 4, 1 and 3 adds to 4, so that's good. We haven't finished though because we still have this 1 coefficient on the Pascal triangle row. So I'm going to go on the next row down and add 1 times 2x, reduce the power by 1, which is a 0, and increase the power of the minus 5 by 1, which is a 4. Okay, and then we can simplify that. So we're going to have, well, this coefficient of 1 here is not really necessary. We're going to have 2 to the 4, and I'm going to take this from the book so I don't get any maths wrong. 2 to the 4 is 16, so we're going to have 16x to the 4. And the minus 5 to the 0, it's a power of 0, so it's just going to give me 1. Then we will have plus this term here. In fact, I'll do some highlighting. This term is that term there. This term is, when you do that, you're going to have 4 times 2 cubed times minus 5. That's what you're going to have here. The coefficient will be 4 from that 4 there, times 2 cubed from the 2 and the cubed, times minus 5 to the power of 1, which is just minus 5. Okay, when you do that, you're going to get a negative, so let's change that to a negative, and it's going to be minus 160x cubed. Okay, that is correct. Now we've just got an x cubed here because my second term, we've not got any y's, because my second term was just a number, so it kind of adds to the coefficient, if you like. Okay, the third term, if you do it here, we'll highlight it in red, is going to give you a positive because we have the negative squared, so that's going to be positive, and the coefficient is going to be 600, and we're just going to have x squared, okay? And that 600 comes from a 6 times a 2 squared times a minus 5 squared. That's my third term. And we'll highlight that in yellow for the second one, and the third one is that. The fourth one is a negative, and it's a negative 1000x, and of course that comes from the 4 times the 2 times the minus 5 cubed. Minus 5 cubed is going to be a negative, and then that's where the negative comes from here, and I'm going to need a green. That's where that term comes from. And then the final term is just, well, we have a 1, that's not going to help. We have 2x to the 0, that's also going to be 1. So really, we kind of don't need those terms. We just need minus 5 to the 4. And that, when you put into a calculator or work it out, is plus 625. And it's just basically that bit there that gives me that term. Now you hopefully can see that we have an expansion here with an x and a second term as being a numerical, so we don't have any algebra in the second term. So all we're going to have is decreasing powers of x. We'll have x to the 4, which we do have, then x cubed, x squared, x, and then x to the 0. Basically there's no x there. Okay, it's just a constant. This is our expansion to that bracket there. Hopefully that makes some sense. Really, just practice this. Practice writing out Pascal's triangle, finding your coefficients, and then decreasing the powers of this first term and increasing the powers of this term. And then just use a calculator to work out what your coefficient is going to be. And make sure the powers are correct. Okay, example 2 in this video is a little bit different. It says the coefficient of x squared in the expansion of that, which is 2 minus cx cubed, and it's all cubed, is 294. We want to find the possible values of the constant c. Okay, so what I'm going to do is, well, I'm going to, again, work out Pascal's triangle. We have a power 3 here, so we're going to look at the 4th row down on Pascal's triangle. It's row 3, but it's the 4th row down. So let me quickly write out Pascal's triangle. It looks like that. So we're looking at the 4th row down here because it's an expansion with a power of 3. So those are my coefficients. Okay, coefficients, the numbers in front of all the terms, are those there. The coefficients are 1, 3, 3, 1. Okay. Also note, if I put a little line down here, we actually have some symmetry. We have a 1 and a 3, and then if this was like our mirror line, we have a 1 and a 3. If I was to do some more work on that, we'd have a 1, we'd have a 4, we'd have a 6 down the mirror line, we'd have a 4, and we'd have a 1. And again, we've got symmetry. We've got 1, 4, 6, and then 6, 4, 1. Okay, that's just a kind of a fun fact of the symmetry there. So these are my coefficients that we're dealing with, and I want the expansion of the coefficient of the x squared term. We know what that is, so I want to do the expansion of x squared and see if I can set whatever I get in terms of c set that equal to 294. Okay, so how am I going to do that? Well, let's just expand it as we usually would do, and then just take out the x squared terms. So pause and have a go if you can do that, and then press play, and I'll do the expansion. Okay, so let's start with our coefficients. If we expand this, I'll have 2 minus cx cubed. We will have the first term, or our coefficient, sorry, the first coefficient. Then we'll have our first term, which is a 2 to the power of 3. And our second term is minus cx. That's, of course, going to be a power of 0. Then we're going to add the next coefficient, which is 3, just taking it from Pascal's triangle here, It's a 3. We're going to multiply that by our first term by a decreased power of 1 and increase minus cx by a power of 1. Then add to that 3 times 2 cubed times minus cx to the power, to the power 1, and that to a power 2. We're decreasing the first term, we're decreasing 2 each time, we're decreasing the power of 2 each time, and increasing minus cx by 1 each time. And then we're going to add 1, because that's our next coefficient, 2 to the power of 0, because we're decreasing that power. And then the second term, minus cx, we are increasing that power. Okay, so that's the expansion of the whole of the bracket. But now what I want is the expansion just of x squared. Why do I want that? Because that's the only thing we're being asked to do. That's all we're being asked to consider, really. Okay, we know what the coefficient is in this expansion. So what are my values of c? If I set that equal, I should be able to work out c. So from here, which of these 4 terms is going to give me an x power of 2? It's clearly going to be that one there, because that's the only one that has c or minus cx squared. That's going to give me an x squared. That's going to be an x to the 0. That will give me an x to the 1. That will give me an x cubed. So I don't want any of those 3. I want this term here. So the x squared term is this. It's 3 times 2 to the power 1. I don't really need that. We don't need the power 1. Minus cx squared. Okay, that's what the term is. Now it's a squared, so I also don't need that negative. So it's going to be 3 times 2 times cx squared. Let's do some manipulation on that. 3 times 2 is 6. Cx squared is c squared x squared. Okay, now what is the coefficient of that term? The coefficient is 6c squared. That's what the coefficient is, okay? It's the number outside, or what's multiplying by x squared. Even though c is a letter itself, we're trying to find possible values, and note it says values here, so they might be plural. Notice that it says the values there, so it's a constant c. So that whole thing is the coefficient, not just the 6. The coefficient of x squared is 6c squared. So that's the coefficient, but we actually know what the coefficient is. We know that the coefficient of the x squared term is 294. So what I can do is I can set 6c squared equal to 294. 6c squared is equal to 294. Hopefully you can see why I'm able to do that. And now it's quite simple. I can just solve for c. What I can do is divide both sides by 6, and that's going to give me 49. I'll have c squared is equal to 49. And then I'm going to have 2 values for c. C is going to be the positive or negative square root of 49, which of course is positive or negative 7. And we kind of knew that we're going to have more than one because it said value or values. Our questions are always grammatically correct. If they're not, then it can lead you maybe down the wrong path, and that's not fair. They're always grammatically correct. So we've got a plural here, we've got values, so we're going to have more than one value of C. And this is always the case. C can either be positive or negative 7. That is your final answer there. Okay, let's have a look at the final example for this video. Pause and have a go at this one. It says find the constant term in the expansion x squared minus 1 over 2x all to the power of 3. So how on earth could we get the constant term from that? So pause and have a go, see what you can do with that, and then press play and we'll work through the answer. There's 2 ways of doing this. What you can do is you can either spot which kind of expansion and powers and coefficient from Pascal's triangle is going to give you a constant. Or what you can do is just do the expansion of all the bracket, do the manipulation, and then take out the constant from that. I think I'll do that because that's a little bit safer. You're less likely to make mistakes there. So let's do that. The coefficients are going to be, and I'm not going to write the full expansion of the triangle down now. I can see that it's a power of 3, and so we're going to have 1, 3, 3, 1. Okay, those are my coefficients, so let's do the expansion. I'll start with the 1 coefficient, and I'm going to have the first term, which is x squared, to the power 3, and the second term to a power of 0. And then I'm going to add the second coefficient times the first term, reduce the power by 1, and then the second term to an increased power of 1. And then we're going to have the third term, which is a 3, times x squared, we're reducing the power, so it's going to be 1, and increase the power of the second term. And then the third term is going to be 1, x squared, I'm just going to move this over, x squared to a reduced power of 0, and then minus 1 over 2x to the power cubed. Now, I don't want to waste time in an exam, so I now don't want to expand all of these, or manipulate them if you like. I want to see which one of those is going to give me the constant. This is the fully expanded bracket of this. We've got a power of 3, so we should have 4 terms, because we always have one more than the power, which is what we've got here. And I need to basically work out, where am I going to have a constant? A constant has no algebra in it, it's just a number. I can see it's going to be this third term here. Now, why is that? That is because I have in the first term here a power of, well, x squared to a power of 1. We don't need that power of 1, so it's just x squared. And then this second term here is to a power 2. So I'm going to have 2x all squared on the bottom to give me 4x squared. So really what I have is that x squared cancelling with the x squared there. It doesn't cancel the square out, it just cancels the x squared. Okay, if that makes sense. So I'm just going to take this term here and manipulate that one. So the constant term comes from the one in the red box. And then we'll just do manipulation on that. So we'll have 3 times x squared to a power of 1 times minus, don't forget your sign, 1 over 2x all squared. We'll have this, we'll have 3x squared, and it's going to be a minus, and we're going to divide by 4x squared. Hopefully you can see what I've done there. I've brought that negative out to the front, oops, but then it's squared, so it's actually not going to be there. My mistakes, we won't have a negative there, because we've got the negative squared. But we will have the x squared on the top and the 3, and then on the bottom we'll have 2x squared, which is 4x squared, okay? And then I can see that the x squareds are going to cancel each other out on top and bottom, just to leave us with 3 over 4. And that is our constant term. That is the constant term when we expand that bracket there.